Welcome back. We're streaming again. I'm 20 minutes ahead of time because the stream was scheduled for 11 p.m. Eastern time. But I'm here earlier, so I thought, hey, maybe we'll take a quick look, 15 minutes through some other tutorial before we start continuing with the what we call last stream CommonFS, Common File System library. So before we start that, let's look at some tutorials. Alrighty. So in the NIM documentation, we can go to, we went through Learn NIM in 5 minutes. We went through NIM Basics tutorial. And we went through, what was it? NIM by example. So, we went through some tutorials, but we never even looked at the tutorial, the official tutorials, all right? I recall that they were a little bit fast-paced, more of an overview of the language, more like learn NIM in 5 minutes, just a little bit longer. So let's look at the tutorial part 1, okay? We'll see what we already know, what we maybe didn't know. So this document is a tutorial for the programming language NIM. Other resources. Yep. Oh, good point will be also to go to the NIM manual. I started reading through it and wow, it's interesting. There's also something called NIM style guide, which will be interesting. I guess when we'll have a little bit more code, maybe we'll be able to start looking at it and apply it to correct the code, make it look better. So what do we have here? The first program, we start a tour with a modified Hello World program. What is your name? We wait for the read line. Wow, the first snippet of code. We already learned how to get user input. And we can echo it. So let's copy it because I wanted to check something. I mean, I already did something, so we have this code, right? It should echo, what's your name? Space. And then in a new line, it should start, it should wait for our input and then spit it out, hi, right? So when we run it, what's your name? Ben. There we go. But what if I wanted to have that Ben at the end here? Like, this space suggests that I guess they wanted that. So look that we have this read line from standard input. This looks a little bit like, it's waiting, in this case, read line for a file. Is standard input a file or some kind of stream? So what instead of echo, we'll do something like write. We have write line. So whatever, write. And we give it, what is your name? Right. But I guess we need to specify the file first, right? Because it's like, so std out as the standard output. We save it. And when we run it, it asks for what's your name, but it didn't insert the new line. So we say Ben, and we have hi Ben. Awesome. So I guess we could do that, which is pretty nifty. If we really wanted, we could do echo inline or echo append echo. Sure. And we'll define a procedure append echo, and it was taking the what was it? Args. And that was var args. It was defined in some funny fashion, right? It was typed GC safe. String? And I think we could do something of that sort. I don't remember now. That's the thing. It was some fancy stuff. and we do this echo args, or something of that sort. I recall that that's how it was defined, and not ampersand, it was the $sign. Save. Nope. Or args string. That works. So we could, oopsie. We could do append echo. And we wanted not echo, we wanted to write. Oh, whatever. We would need to write to standard output. And here we need to join everything together. Which would be basically typed. Was it something like this? I recall that this whole typed thing made it interesting. Can I control click on echo and see its implementation? Yes, we can. For args typed. Oh, and instead of just $sign, we need to specify it in those backticks to make it work out. Okay. It's magic echo. It's benign and has side effects. Okay. So let's copy that. And how do they process it? We don't have the implementation, but I guess we could find implementation somewhere. Maybe not here. Echo, 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 everywhere, echo. But nowhere it's being actually defined. Oh wow. We can figure it out, right? So we have this whole thing here. And we can say that it's, what was it? Side effects? Something of that sort? Side effect. Okay, we've got that done too. So it's more fancy. And now it's unhappy because typed in the context of proc. Let's just try to implement it. Write standard output, so let's make it that for strings is what would it be? Nothing, and this will be a sequence of string. Okay, we have empty sequence of strings, and we'll do for args. No. Why it doesn't like invalid type typed in this context? Okay, never mind. We'll just give it string, right? It's just var args of string. This way we can just do this whole thing. Var text is this, and then we do for string for whatever arg and args text, and the append equal arg. Okay, we'll just add them together. And we just print it out like this, text. So we should just do append echo. What is your name? Save it and run it. What is your name, Ben? Yeah, there we go. I'm sure it can be done a more elegant way, the way that automatically applies the $sign. I just don't remember where it was. It was in one of the tutorials. That was our first program. What else did we learn here? Compile run with arguments. With the run switch, nym executes the compilation, give it your program command line. Okay. You can shorter compile to C and run to -R. And that's how we make a release with a flag -D, flag D, :release. Okay. Some bunch other of compilation stuff, bunch of readline stuff, and that we can make it var or something. Okay. Lexical elements, string and character literals. Yeah, we can make a raw string with the R. We learned that. Triple quotes. Normal comment, multi-line comment, numbers with those separators, hexadecimal, binary, and octal. Yeah, octal literals. Yep. The var statement, exactly. We learned to do this and that. We learned about constants and that we can do some basic calculations there. The let statement that we can assign only once to. And that constant is purely, is evaluated during compilation, so something like readline doesn't work. But with let it works because it's runtime. Then we have the assignment statement, where we can assign values. Okay. The assignment operator. The assignment operator can be overloaded. You can declare multiple variables with a single assignment statement, and all the variables will have the same value. Okay, that's new. So we have var xy is 3. So assign 3 to the variables x and y. Okay. Cool. And changes the x, of course, without changing y. Great. Control flow statements. We have if statements that we learned about. Nothing new here. There can be 0 more elif parts, the else part. Okay. Great. And yeah, the quote is just an empty string. I guess it was used here where we define if a name is an empty string. Case statement. Yep. Of this, of that, and else as whatever else. Okay. And then with some ordinal type from standard utils, import parse int. Look at that. So we can import just something from just specific thing from the whole library, just like you would do in JavaScript or in Python, I guess. So that's cool. And we echo something, ask for an int, parse the string into int, and depending on that int, also we can do if it's in that range or in that range. Also you can do with ranges, okay. And then those numbers. That's great. However, the above code does not compile. The reason is that you have to cover every value that may contain, but the code only handles the value from here to here. Yes, exactly. So we would need to have the else discard. Okay, makes sense. We went through that. While statement. So our loop, our while loop. This is all standard. We learned about it. For statement. For I and count up. Yep. And count up, returns values, all those, yeah, it just explains the code. Okay, that makes sense. So here we need to remember to increase the I so that we actually get to somewhere. Using the ranges and for loops. And yeah, they're just with the excluding the top number, the length, getting the length, iterating over index and the value. Okay. And the last element. Other useful iterators for collections like arrays and sequences are items and m-items, which provides immutable and mutable elements respectively. M-items, huh? Okay. Pairs and m-pairs, which provides the element and the number and the index number. Okay. Okay, so we do basically that array and we ask for pairs, or we could ask for m-pairs. Okay, and I guess m-pairs would work only if we have a variable first. Okay. Scopes and the block statements. So yes, we have this, and here's out of scope. The same with block. Break statement, which we can basically break just out of the loop. Or here we can break my block too, which exits the whole block. So it'll be like outside of the block. Great, we learned that. Continue statement works as expected. Then we had the when statement. When system host OS is Windows, do this, and we can actually use elif and else with when. That's good to know. That makes it a little bit less tedious to do a bunch of stuff. Okay, and each condition must be a constant expression since it is evaluated by the compiler. All right. We still have 5 minutes. Statements and indentation. Just a second. Looks like YouTube doesn't like my stream values. Please use a keyframe frequency of 4 seconds or less. Currently, keyframes are not being set often enough. Okay. Let me check OBS if I can do something about it. Keyframe interval. I guess it's in seconds. Let's do every 2 seconds. Okay. And maybe that error will go away. We'll see. Going back here, statements and indentation. Now we covered basic control flow. Complex statements can contain other statements. So yeah, we can basically indent and nest things in each other. So that's good. Okay, expressions are parts of statement that usually results in a value. Okay, expressions can contain indentation at certain places for better readability. So we have if, and looks like we have double indentation here, I guess, for readability. And yet another additional indentation here to just finish it off. Okay, it'll be interesting to figure out those rules at some point to make code a little bit more readable. I liked to actually continue with and here, so you can read if, and something, but I don't know if it's allowed. We could figure that out at some point. And with parentheses and semicolons, you can use statements where only an expression is allowed. Okay, so constant, and we declare variable x is 1. And then for I, and it's like this little statement, then we do iterate from 1 to 4, where we multiply it. Okay. And then return the x at the end. Okay. That's actually very handy to do something like that. And I believe we could also define a block as well. Block, colon, and return value from there. Okay. And we already get to procedures. The concept of procedure is needed. Yes. And a procedure, which takes an argument and returns something. We do stuff inside. We return those. Okay, and then basically if we use that procedure, okay. Named yes, asks for a question. This explains what it does. The return statement leaves the procedure and therefore the while loop immediately. The question string describes what procedure expects. Okay, we know all that. Some terminology. An example question is called a formal parameter. So question up here, so this is a parameter. The should I is called an argument that is passed to this parameter. Okay, so when we define a procedure, we define its parameters, but when we're calling a procedure, we pass arguments. Good to know, especially for me when I'm trying to explain things. I can make sure that, they are somewhat correct. YouTube. YouTube is still complaining about things. Yep. Don't know. Let's refresh it and see what's going on. We'll see if it's okay or not. Right now it says it's healthy, but maybe we'll be complaining again about problems. Okay, so it's 11 p.m. here in the US and Eastern time. So, again, welcome back to the stream. I started a little bit earlier, started going through the official NIM tutorial, just quickly perusing through it to pick out things that we haven't learned yet. And that's basically it. And in today's stream, we can continue working on the CommonFS interface library or abstraction library. CommonFS as in Common File System. And that's what we named it in the last stream. And as we're designing the interface, we'll be trying to write the first implementation of it, which will be the OsFS, OS file system, which is actual, implementation of the interface that is specifically for interacting with the, actual real file system, for which we can use the NIM standard library. So during last stream, unfortunately, through the second half of it, I left the stream in exactly this view where we have basically my face in the background while I thought I'm showing my screen and going through the documentation for NIM standard library, picking out different parts of the standard library that are responsible for the file system features, and then going through the Affero library for Go language. That is kind of inspiration for this library that I want to write, and comparing things. So the result of that, you can for the first time actually see. Where did it go? Here it is. So this is the result of it. So from the NIM standard library, we basically made a list of all the ways that interactions with the file system happen. Things like, hey, create directory and give it a path, check if it exists, copy directory, maybe set current directory and get current directory, right? All those little things. We went through things regarding files. Also things like just reading from the file, writing to the file, maybe deal with permissions, get information about the file, things, like modification times, the file size, etc. And we looked a little bit at streams, how streams are implemented, and a little bit more of notes what is basically stored about the file in the nim standard library. We have different ways that we could technically work with a file when we read from it. We could read everything as a string. We could read just bytes. We could read specific number of bytes. There are all those options that we could technically configure, but I don't know if we'll get, initially start doing with like, oh, I want to have an implementation where I read from that to that part of a file. Because maybe it's not something that would work for other file system like FTP, etc., etc. We wanted to make it like a simple interface that allows you to deal with files in a manner that won't give you a headache, but at the same time won't give you total control like you would have if you would go with those low level instructions. And also the same thing goes for writing files, to buffers, to lines, etc. And we could even have iterators and whatnot. A lot here, okay? Or template for appending to a file. So many possibilities. Then, like I mentioned, we also looked through Affero, how Affero does it. And Affero is inspired by the Go language standard library, so everything looks a little bit different. Again, permissions, creating, making directories, getting the name of the file, opening it, reading things, removing, using streams to write and read. All that stuff, and then also pretty much the whole thing again. And that's basically what we scraped through the second half of the last stream. So the idea would be that now we'll be able to actually go and try to implement it, select what we actually want and what we don't want. So what I'm going to do is I'm going to copy basically this whole thing, and let's copy it. Let's add it to like a new little file. Let's call it possible file system commands. Okay, we'll just paste it here so that we have everything, because the idea is that we can just go here and simply I can make it even larger. That's the largest it gets. So now we can just start crossing some things off. Let's think about the simplest implementation that we can think of, where we can operate on directories and we can operate on files. Okay, the bare minimum would be, we need to be able to create directory, right? Just give it a name and this is directory. We should be able to check if the directory exists, of course. And I can already say that we need the same for create file and file name and file exists. Okay. If we have those two counterparts, we can create empty files and we can create empty directories. That would be great. And check if they exist. That's another thing. Exists or create directory. We can get the same result with just that. So let's ignore it for now. Move directory. I'd say we can get by without it, because what moving directory is, you will basically need to take the files, list them, list the files, or more like, okay, where do you want to move the directory? So create that directory there if it doesn't exist yet. So we use our create directory. And then for each file and other directory that are within it, we can just create files, copy whatever was content from the other file to this one and whatnot, and create other directories within it and whatnot. And that's what move directory would be. Technically. The difference is that moving directory, I believe, would preserve all the metadata about files that are being moved with it. Therefore, it's not like, oh, this file was just created, it was moved, therefore creation time stays the same. The same thing, I guess, goes for permissions. So I would say a bit later, okay, let's have a separate category a bit later, where we can implement move directory and possibly copy directory, right? Copy directory with permissions. Let's not delve into permissions at all for now. Remove directory. We definitely need that. So remove directory. And let's just do that. No checking, nothing. We should also have remove file. Okay. So we'll be able to remove them. If we have move directory and copy directory, we should be able to do move file. Okay. And copy file. Same thing. Set current directory and get current directory. I really like that idea, therefore I will leave it for a bit later. The whole idea is that for an instance of a file system that we created, we could basically have a functionality where we can specify the default prefix for when we're dealing with relational or with relative paths. Okay, so we're not starting from, it will be where is the current directory that we're working on. Therefore, we could actually utilize the relative paths, because without having the current directory, this concept, we couldn't use relative paths. So then what? Iterator to walk through a directory. 100% we need that, because that's the only way to really explore what the contents of a directory are. And walk directory recursive, we should have it. It's basically go through a directory, all the subdirectories and everything. So I guess these are the two things that we really need to be able to allow for exploring the file system. And check if file exists. We already had that. Move file, remove file, copy file to directory. Just, annoying. With permissions, get file permissions. That's another thing that we will need to start dealing with permissions. And I actually don't know much about permissions. So that's interesting. Let's leave it for now here, okay? Let's do just not copy file with permissions. Let's just do get file permissions and set file permissions, okay? And the same thing will be not for file, but directory. Okay. Just to have those to consider. Move file, we already have that defined. Remove file, set file permissions, yes. Try to remove file. Let's ignore all those tries and stuff. Then we have something very important, get file info. So the idea here is that we can specify a file, and in return, we'll get, like last modification time, last access time, creation time, file newer. Not sure about that, but get file size. That's another thing that we would like to check whenever we get information about a file. What is its size? So I'd say this is very much required. Okay. Permissions, all that. Good. So let's continue. Read file. Yes, that's the important part. Read and write file. We should be able to do that. Now, the thing is that there are a million ways to read and write files, right? I'd say we should limit ourselves to like two most basic approaches. One is dealing with strings, and the other one with something else. So let's think about it, how we can do that. Let's not delve into streams yet, because I personally simply don't know how streams work here yet. It's something that we can get into, but for now, you know, at least I don't have enough information. So read and write file, okay? And that will be here. We, of course, there's no concept of reading and writing a directory, so we don't worry about that. So read file, either to string or something binary, right? And we would just need to specify the file name, okay? And when we write file, we will need to decide if we want to append to the file or if we want to overwrite the file. And of course, file name. And mode would be basically append or overwrite, right? So what else? We have the thing, file streams, we don't worry about it now. File info. So this is basically a little hint of what we actually can get from a file, which is kind and size, permissions, number of links, I guess, okay, Linux stuff. I don't think something like that we'll be able to get from, you know, FTP. So this is the limitation. We don't worry about it. Last write time, all those things. Block size, again, we won't get those details from S3 bucket or FTP. Is special, whatever that means. So let's just get rid of that. We're not worrying about that right now. And then we had all those kind of existing ways of reading file already in them. So I guess we could try to utilize it, as in just have consistent names, right? So read all will be the string. We just get the whole string. So yeah. So let's have it as read all, okay? And we basically, instead of read file, we do read all. And instead of giving it a handle to a file, let's just do file name. Okay, let's keep it simple for now. Read buffer. Let's not deal with pointers for now. We're not familiar with it yet. Read bytes. That's something I'll be interested a little bit more in. In theory, a string is just bytes, but I don't know if string can properly contain all the values without freaking out or something. So it would be nice that if we could just read the bytes, right? And I would skip the start and end. We just read the whole thing, okay? So read bytes, that will be another one. And we just give it the file name and an open array that will add stuff to. And I guess we could also specify int as how many characters we read, right? Wouldn't hurt. Open array, I'm not sure how to use it exactly yet. I just recall that an open array is basically an array that can kind of grow, but can be accepted only as a parameter for a procedure. So that's something we could read up on. So we have bytes, single character, or just characters. It's all strings. Then we have read file, which is again the same thing with string. Okay, read line. It'll be better if we can read the whole file and then just go over the lines, right? That's another thing. Read lines and whatnot. It's all just could be used in later post-processing. And then we have the writing, right? How we want to write things. So, oh, look at that. String and this. Huh. Let me check if that actually works. While we're here. String and we do this. Does it work? It works. Doesn't mean I can do 15 and run it. I'm just dying to check it. Yes, it works. Okay. So we just solved this whole thing. That's awesome. Okay, never mind. Let's get back to what we're actually doing. So we could write string or strings. This is basically similar to echo. A bool or a single character, not really. C string, we don't care about those things. Integers, this kind of takes care of everything. So let's skip all those weird things. A single string is already handled by this. Then we have write buffer. We don't want buffer, but we want the bytes. We want to be able to start the bytes. And again, we don't want to do much with the starting point on whatnot. We just want to write it. Characters, write file name, content. Again, basically the same thing. Okay. Okay. And this is interesting. Well, other things specifying that. This looks a little bit simpler to utilize, so we'll focus on that. And then we have write line, and again, some weird types. Okay, so we ignore that. And we can update our write file, which will be, oh yeah, the mode and comma, what was it? Let's undo the things because we just cut everything out. Comma this. So this will be write. Just write. Okay. And then will be write bytes. But we'll use this implementation. So we'll do write bytes. We just include the mode, and content will be this. Okay. That makes sense. And here again, we can just use the simpler definition here. Alrighty. Oh, I see. So this open array is integer, something like byte or unsigned integer, so we could pass in whichever and it could work, I guess. But I prefer this, so let's stick to just byte, okay? Let's just stick to a byte for now. Okay, instead of those semicolons, let's just use the normal comma. Okay. So we went through that. Then we got a iterator for lines that we don't care about. Weird appending or read lines, we don't care about that. Hey, looks like we're starting to get some idea of an interface. What we want to implement initially. And the most immediate ways of expanding it. Okay, let's just take a gander from Affero if there's something that we could change. Operations on the file system itself, we just change again the who owns it and stuff. We don't worry about it. Creation, get information. making directories, getting a name. I don't know if we'll have a concept of file yet. That's another thing that we need to think about, because in some way we could have a situation where we are, what would you call it? We could have a situation where we ask, for example, hey, open this file, or like get me this file, and we just get like an object that's a handle for a file, and therefore we could write to the file, we could do all those things, and we wouldn't need to, because there will be situations where you want to write to the same file multiple times while you're doing things, right? So it would make sense to just get that file, do stuff to it, and then, close it, as in finish working on it, instead of calling something like write bytes and provide it every time with file name and every time with append and override and all those things. So maybe a concept of a file would be a little bit more, practical here. Then we could go, open file and get info or whatnot, just many things. And trying to open the file would also check if the file exists. So, there are things here to consider. So that's when, let's say you open a file, you could call on it, hey, give me the name of the file. And, even though you use some path to do it, to set it, you could just read from it, because why not? The same thing with open and other things that would return the file itself. Okay. Read the link if possible. Real path. Yeah, so that's other things that we could add to a file. Like, hey, give me like absolute path to the file, or rename it. All those little things. But I would hold off with those, right? Let's just have the initial where we can maybe get a file and do something with it. So let's do something more like for files. File exists, remove file, whatnot. Let's do open file, right? And file name. And that will return a file, okay? And then on the file, we can do all those fancy things. Okay. I wonder if we will need the similar thing with a directory, where we can get directory and create files in it. I guess that would overcomplicate things. I guess that would be something that we can add on top that could reuse some of the base functionality. Maybe. But let's not get that far yet. So we have opened the file and all that stuff. And that's it. Streams, we don't worry about it yet. Getting, name, read directory, this will be list everything list all the files that are already, in the parent directory, all this stuff. Let's not worry about it. They would have check if the directory exists, the things that we're listing, check if the file contains any bytes. That's another interesting approach. Get temporary directory, searching for globs. That's another great idea. Checking if whatever's under that path is a directory or is it a file, because on Windows, whoever uses Windows, it's familiar that, hey, every file always has some kind of extension. But especially on the Linux side of things, when you have an executable, it doesn't have an extension. It's just a random name. So you would need to be able to differentiate whatever is under this path. Is it a directory or is it a file? All those things, but I don't think we need to implement any of those initially, right? Yeah, walking, we already have that defined. Yeah, so from here, we just get rid of everything. So let's just focus on this specific set of features that we have here. Starting with creating directories. Yeah, let's try with starting with directories, okay? Just basic directory things. Let me just check what our notes here. We're creating a file system. We could specify additional config. Yes, and what about file access permissions? We'll worry about it later. Bam. So create directory, okay? And we just give it a directory path. I like it. So let's see what we can do here. Let's get back to our code, to our common file system, okay? Let's skip all the check if file exists and this and that. We'll just use it as a template, okay? So we would want method, what was it? Create directory, okay? We want to make it public, or export it, I guess that would be the correct word here. And of course, we want to be calling it on a file system because we can have various different file systems. And it could be real file system, could be in memory, could be S3 bucket, and one program can be, you know, have instances of all of them at once if that would be necessary. So we need to have a reference to self file system. Okay. And we need to path to the directory, right? And let's make an actual path. And let's make it base. Okay. And then implementation, let's just do an error that it's not implemented yet because this is not where the implementation should go. So method blah blah hasn't been implemented yet. But now, how do we want to handle errors? That's another thing that we didn't really cover in any tutorials, I believe. None of them covered handling errors. So let's go to our untrusty Claude and ask it. Let me think. I'm learning NIM. How does NIM implement error handling? Let's see, a very generic question. I hope this is gonna be somewhat right. In NIM, error handling is primarily done using exceptions. NIM's exception system is similar to that of languages like Python or Java. Here are the key points about error handling in NIM. So we can raise exceptions. Exceptions are raised using the raise keyword followed by an exception object. So that's what we have here, right? Raise, new exception, what type, and some text, okay? NIM provides several built-in exception types such as value error, IO error, OS error, etc. You can also define custom exception types by creating objects that inherit from the exception base class. Okay. Try except blocks. Okay, exceptions can be called and handled using try and except blocks. The try blocks contain the code that may raise an exception. The except block is used to catch and handle specific exceptions. You can have multiple except blocks to handle different types of exceptions. Okay. Classic. Finally block. The finally block is used to specify code that should be executed regardless of whether an exception occurred or not. It is typically used for cleanup and resource deallocation. Yep, that's standard. And then defer statement. NIM also provides a defer statement that allows you to specify cleanup actions that should be executed when the current scope is exited, regardless of how it exits, normally or via exception. Yep, the first statements are executed in the reverse order of their appearance. So this is something that I know, for example, from the Go language. And here's an example of the concept. We have divide. If we try to divide by 0, it will just raise the new exception. And if not, we'll do that. So then we can have try to do our stuff. It is a value error. We have invalid input. I guess parse int could do that. Divide by 0 is another. And then all the other errors will be, like other unexpected error. And finally, we just, could clean some code up if we needed to. Okay. And defer. Echo. This will be executed at the end of the... Oh, okay. So in Go, I'm used to a situation where you say defer and just provided a function name. Here we can actually specify the whole block. That's fun. Okay. So NIM's error handling mechanism allows you to gracefully handle exceptional situations, provide informative error messages, and ensure proper cleanup or resources. So this is pretty classic. The thing is, I hate raising exceptions. I hate handling exceptions. It's just really annoying. I wonder, because so far we saw that NIM has so many ways of tackling problems. It's not a language like Go where you do things this specific way and that's it. I feel like NIM is more like, hey, here are the tools. You have a whole variety of them. You utilize them however you like. So I wonder if we could have an equivalent of what Go does. Does NIM and have an alternative way of handling errors? I really like the way Go language does it, as it's very explicit. In other words, is there any other way of handling errors in NIM that is considered idiomatic? Because by idiomatic, we mean that we want something that isn't considered a hack. It's something that is actually intended to be used in a specific way, that, this is how it's supposed to be used. So let's see what this will tell us and what we could see here. Yes, NIM provides an alternative way of handling errors that is similar to Go's error handling approach. In NIM, you can use the result variable and procedures to return an error value along with the actual results, just like Go. This allows for explicit error handling and propagation. Here's an example of how you can handle errors in NIM using the result variable. So we specify my error object with some kind of message, and we have procedure, divide, whatnot, and it returns a tuple of float and my error. So if b is 0, we just return the tuple of default value for float and your error, right? And if everything is okay, we just do everything an empty error. I'd rather return a nil. And then we have procedure main, let value, this and that. So we basically specify that outcome of division is this thing. And then we can check if you're checking if error message is empty. But you could do something like this. Okay, that's one option. This approach allows for explicit handling. It also provides try statement that can be used with result variable for more concise error handling. What? So we have this raise exception, right? Standard thing. And then we do try, accept. Oh, so this is the old stuff. I don't like it because you can just accept and ignore the whole thing. Okay. Both approaches are considered idiomatic in NIM, and you can choose the one that's the best fits your needs and coding style. The explicit arrow handling using result is similar to Go's arrow handling. Yep. I wonder if how popular this approach is. The other thing that I'm aware of is also library like, for example, NIM result. I looked a little bit around GitHub for interesting projects. So friendly value or error type. So this is a result type that can hold either a value or an error. This is something that is similar to how Rust, for example, can handle errors. I believe it was Rust. So add the following to your Nimble file, right? Requires a result. Or just drop the file in your project. Yeah, sure. An example is we import the results, right? Then we re-export the results so that API is always available to users of your module. So that's a good idea. And it's convenient to create an alias, most likely. So here we basically make an alias named R as a result. This is a result of integer and string. Once you have a type, use OK and error. Yes, that's where we're actually talking. Okay, so we have a function works that returns that type R. And it says R OK and will provide the value, which will be this integer here. While a different function fails, results in error. And in this case, error is a string. So we just give this here. Okay. Then we have function also works. So another one, whatever. And so we can basically check if we create variable works, W, which is the return of works. And then if W is okay, we can just echo the this thing or use dot value. Okay, that makes sense. And this is, yeah, okay. So if it would be not, I guess we could just ask for an error. Okay. In case you think of colors, in case you think your colors want to differentiate between errors, you can create an error enum, A, B, and C, and basically make it return, okay, something or an error. Okay. So we had this, works fails, right? To accept, if you can use the question mark operator to pass errors up to the call stack. Wait, what? Works minus fails. Pass errors up to the call stack. I have no clue what this does. Because works and fails, they will both return those return values. Assert false. Will never reach. Oh, because this will throw, right? I guess this one won't throw anything. But this will throw, and therefore, I don't know, will throw an error with a message? That's a good question, what this question mark does here. If you want to provide this exception converter, this exception will be raised on try get. So we have function to exception, okay? When we take an error, which is just an enum of A, B, or C, and it returns catchable error, reference to a catchable error. So we basically do reference, we take the message something v. Oh, so we take an error and convert it to a string, and we call it a message. And I guess we cast it to a catchable error. whatever catchable error is. And so then we can use try. We can use try and call this thing. So we have integer or.error, error.tryGet. This is getting a little bit confusing here. You can use option T as a replacement for option. So I guess this instantly provides an optional integer. So is an alias for result T void, meaning you can use the full result API on it. Okay, so I guess, oh, I see. So an option in this case is like a nullable. So either it returns or it doesn't return. But you're not checking for nil. You can basically check if it's okay or not. Okay, I see. Or result void E as a replacement for bool, providing extra error information. So result this that dot error computation failed. Okay. I kind of like this approach because this is what some other languages have as default, and that still has a situation, you know, when you're choosing basically between a solution like your try catch, where you have the whole long block, and at the end you have something that, oh, when something happened, we're gonna handle it down here. After we when reading code, you will forget often what this was referring to. Or you have to have things nested inside of things, inside of things, inside of things, which is, another mess. Then you have an approach like Go, which just returns those additional values that you need to check if they are empty or not, or whatnot. I don't know how nil works in NIM yet either, so I don't like that solution as much. It works decent in Go, but at the same time, Go is just so simplistic that you can't define those nice is okay, is error, and depending on that will return you a specific type. So, that's not that great. And then suddenly you have the other extreme end. Where was it? Here, where you're dealing with actual result type, where you can define those errors. I'm just really wondering how this would work with existing errors, because I guess when we'll be calling the standard library in NIM, when creating files, they will raise exceptions. So I guess that's the standard way, working with exceptions. And therefore, here we would be, in our implementation of, for example, the create directory, we would be throwing exceptions and then turning them into wrapping them in our result. So maybe just because we're dealing with a library, we're writing a library for others to use rather than our own application, maybe we should stick to what NIM does by default, which is just raising exceptions and dealing with dealing with a life with try catch. I think this would be our solution. Let's try not to go, overcomplicated. Let's just start as simple as possible. Maybe at some point when we'll see that, we're writing those things and using it is absolutely atrocious, then we're gonna consider maybe we're gonna switch to that result. But for now, let's just stick to our try catch. Where was it explained? Yeah, try, do this stuff, accept this, accept that. Millions of programmers deal with that every day, and they can write some code. So in our simple library, I guess we can manage, I presume. Okay. So let's go with that. I recall that if we'll go to the code and then we have something, OS file system. Not really. In our hello nym, we had open, right? Can we go into open and see what happens if it... Oh, we can't go in there? We can. So we have all that, but I recall that sometimes things were defining how wrong something can go. If not, open and resolve this and that. So is that different open? Yes, it is different open. So look at that. We have those additional things like tags. We have raises. And again, benign, which is... What does benign mean in English? I don't know. What does benign mean in English? Because I heard that word many times. I just never cared to look up what it actually works. It means. In English, the word benign has few related meanings. Not harmful or malicious. Gentle, kindly, okay. Of a mild type or character that does not threaten health. Favorable. Okay. To be honest, it sounds totally opposite. The benign sounds like ominous. So I guess opening is benign? No clue what it does. Can I like control click on it? No, of course not. But it shows that it raises and nothing. I recall reading somewhere that in here you can specify what kind of errors it will raise. It says nothing, so that's interesting. Well, it's using fopen. And what does fopen define? Nothing here. It just imports fopen from the C implementation. Okay. So when not defined, blah, 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 return false. So this open, it returns bool if it opened a file or not. Oh, because we provided with a file. Okay, so this thing basically returns a file. If not opened, system fatal, IO error. Isn't that like throw an error? Cannot open? What is this? Raise new exception. So how is it not specified as raising exceptions? Okay. Let's ask our chat thing again. In nym, how can I specify what exceptions a procedure / method can raise? Does nym compiler figure that out automatically? Or do I need to specify it manually? That's a good question. I think it's part of something called effect system. And then we can specify the exceptions that procedure or method can raise using the raises pragma. By default, if no raises pragma is specified, the nym compiler infers the exceptions that can be raised based on the procedure's implementation. So it does it. Okay. Here are a few ways to use the raises pragma. Raises this, so specifying that there are no exceptions. Okay. Specifying specific exceptions and allowing n exceptions. Okay, so it can throw any kind of exception. Okay, if you don't specify the raises pragma, the nym compiler will infer the exceptions based on the procedure's implementation. It will analyze the code and determine which exceptions can be raised based on the raise statement. Blah, 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 blah. Okay, so it inferred some stuff. Good practice specify the pragma when you want to document and make it clear. Can raise. This helps with writing more robust. How can I use those? Michael Cotsworth, hello. Hello to you too. I'm doing pretty well, actually. I'm excited about finally writing some NIM and you know, getting my hands dirty. And how are you? So, however, if you prefer to let the NIM compiler and further exceptions, so the question is now that when we have exceptions, you know, if we mark them up that, hey, this procedure can raise, I know, a value error, how can we utilize it? How can I practically utilize the utilize that additional info that I added with raises? Because sure, we can mark it up, but what's the point? How can we use it? Mitchell Cotsworth says, I'm good, thanks. I'm glad you're good. For some reason, you know, it's Wednesday, I think. Well, in 5 minutes, it'll be Thursday here. But it feels like weekend, feels like Friday for some reason. I don't know why. All right, so how we can do it? Documentation and code clarity. Sure, more code. Compile time checks. Okay, when you specify raises pragma, the NIM compiler performs additional checks during compilation. If the procedure raises an exception that is not listed on the raises pragma, the compiler will issue a warning or an error. Oh, that is fun. This helps catch potential bugs or inconsistencies early in the development process. Okay, that's cool. Exception handling propagation when calling procedure, you know exactly which exceptions. You can use this information to use the try catch. Okay. Okay. So I guess it could raise something. The thing is that we're defining an interface right now, right? We are defining an interface. Let's get rid of this and that. We're just specifying an interface. And it'll be a little bit difficult to figure out, you know, the raised exceptions, I guess, would be different if we were dealing with the real file system. They would be different if we would deal with in-memory file system, where you won't have some of the errors possible. You will have different errors probably possible. And it will be vastly different than, you know, dealing with FTP, where suddenly we're dealing with a network connection and possible network errors. So it will be futile to specify what is being raised here. And then what? In OsFS, when we override those things, we specify them here. But when we're using the thing, we are explicitly returning file system, not the specific OsFS or something else. So we want the idea is that when we're utilizing that library, it shouldn't matter if we specify that we want to use a real file system or a memory one, or I don't know, S3 bucket, because we're calling exactly the same functions or methods, procedures. We're calling basically our code doesn't change depending on which file system we're using. Therefore, the exceptions that we're handling shouldn't be changing either. Because, you know, then what's the point if my exceptions keep changing when I'm using different file system? Then, you know, suddenly maybe the code that you're testing will start behaving differently during your tests and during your something else. So I don't think that's a good idea here. So, okay, this is actually a surprisingly complex problem. Like, usually error handling is complex and painful. I guess that's the most difficult part about programming, handling errors and all the edge cases. So let's think again. If we will be raising normal exceptions, the only thing that would make sense is to specify 1 or 2 exceptions that are allowed to be raised. And that's it. They will be regardless of what kind of backend we're using for the file system. Or we go the route of just specifying that an error will be a string. And then the implementation of your, of handling the exception, it will be a little bit like in Go when we check if it's an error or not. And I guess then, because then it suddenly becomes so painful for the user of the library, because other than getting a generic string, oh, something went wrong, they have no other way of telling what went wrong and, handling situation. Because in theory, you want to be able to handle a situation where your FTP, save file fails because, the file already exists or something, or the file doesn't exist anymore, or no, the connection broke. These are completely different reasons that you would probably handle completely different. If the whole connection breaks, maybe you want to have a bunch of code that will create a new file system, try to reconnect or something. But if not, you'll just, oh, geez, we need to stop the program because nothing else will work. But if you had an exception where only, the deletion of the file failed because the file is not there anymore, or the whole directory isn't there, then you can recover from that. Oh, we'll just assume that it was already deleted because it doesn't exist anymore, or, bunch of other possible solutions. I guess we would need to have a set of errors that are possible to be returned per method, right? Because different things can have different things happen. And on top of that, we would need to have some additional, more like file system error or file system exception, like a generic one that means more, depending on the context of the file system. If it was a file system like regular file system, and I know suddenly, hey, the drive isn't there anymore, we can't operate on it because it was unmounted or something, then you will have that error of file system exception, right? And in case of dealing with an FTP connection, if the connection is broken, you can't reconnect because there's no internet or something, that will be also a file system because the whole file system isn't accessible. Okay, I kind of like that solution. It could be a good start. See how it works, if it will totally suck or not. So let's say for create directory, right? Let's think of what exceptions could be. Let's say that we have that file system exception, or I know, error. Let's call it error for now. It's less to right. Okay? The file system error, the generic one. When creating a directory, it would be, hey, already exists. But then, do we really want it as an exception? If we want to create a directory, and at the end it already exists, I don't care. It's already there, so that's good, right? So I guess that shouldn't be a problem. But there's a situation where we try to create directory ABC, but there already is a file with the same name. That will be problematic. So that could be error that could be handled, right? And it's not of a scope that, hey, a whole file system doesn't work, we're all gonna die. It's just, okay, this thing was already there. Maybe suggest renaming it to the user or whatever. So that's something that could be handled. So in this case, will be path taken or path already taken or something. Path unavailable. Something generic enough, right? So depending if we're dealing with FTP or real file system or in memory, and it won't be truly confusing. And the other would be no permissions or something like that, or what will be no permissions, access denied. What's the proper wording for it? No permissions. Sure, that's good enough. So let's think about. Let's actually go to our list of all those things, and let's do it here. Possible exceptions, right? We have this, that, and permission not available. So let's grab this, all of this, and let's utilize AI. Let's do it for us, because, you know, I'm lazy. So I'm working on a library in NIM language that will be dealing with file system operations. I want you to list possible exceptions for each of the following actions. Okay. Let's just paste it. Okay. We're gonna cut that. Or at least let's just remove that. And let's specify what format we would like it to receive in. So for as an example, the create directory action could return several errors. So and let's just put that in. Okay. It's worth mentioning that the term file system can be both OS file system. It can be any OS file system, in memory file system, S3 bucket file system, SFTP file system, etc. This requires the errors to have somewhat generic names that would fit all the situations as demonstrated in the example above. Please define possible exceptions for the rest of the, what do you call it, actions. Let's see if after all the typing it will help me not think too much. Okay, it follows the whole thing. Good. So if there exists, we have those two. For some reason, for there exists, for checking it, no permissions, Remove directory. Okay, the error could be directory not empty. That's true. That's up to us if we want to take care of that. It ready work directory, file system error, path unavailable, no permissions, so nothing really else is happening. For create file already exists. Anything new somewhere? Open file. File not found, so path unavailable. How is that different for file not found? Get file info, okay, it just takes for all of those. Read all. File not found, no permission. Insufficient buffer for read bytes. Interesting, okay. And for writing, well, it doesn't do much inventing. File system error path. Here we have directory not empty and destination exists for move directory. The same thing for copy directory, because we don't want to copy it to somewhere where it already exists, because suddenly we're getting into very complex logic. If I want to copy this directory to another, I don't think our library wants to, should really worry about merging two existing directories. That just sounds like too much work for us. And it could be handled in a million possible ways. Therefore, that should be something up to the user of the library, right? Or maybe we could create a little separate library with extensions that operate on that interface using those values for an interface, but implementing, those specific extra fancy merges and stuff. Setting correct directory, okay, and permissions and whatever. You have no permission to set permission. Okay, so, well, this wasn't very inventive. They're generic. Okay. Please get a little bit more specific. Anticipate or predict possible errors depending on how they could be implemented for various file system backends. Let's see if it's gonna expand our things a little bit more, because it did the first part of the job. Now it can focus on something a little bit different. So while this is writing, I'm gonna take a little bathroom break, so I'll be right back. Alrighty, I'm back. Let's look what our AI assistant figured out. Alrighty. So for create directory, okay, it figured out what could be the possible things that could happen. For OS error, S3 error, okay, so basically those generic errors, something that we would replace with the file system error. Path already exists, out of memory, bucket already exists, and all those things. Oh, I guess on S3 it's just buckets are the directories? I don't think so, or maybe? I don't even know. Checking if it exists for memory. Well, no need for an error. Access denied. Okay, so what I'm gonna do, I'm gonna copy this because this is gonna be, useful. And as we're going through different, implementations. Wow. Let's Ctrl-Shift-V. There we go. As we're going and implementing different things, we can, start thinking as what could happen. So we've got that. What's this? Oh, I have the same file twice. Okay. So let's go back to our code. And can I just do something like, what was it? This. And we just paste this in here. Let's just remove all those. And why does it try to force spaces? And then using spaces too. There we go. Now we'll have more proper nym code. And this and that and that, okay? So now my question is, we're dealing with methods, right? So if we add something like comma raises or raises, what was it? Raises. Okay, we have this thing. So let's copy it. And let's put that, right? We save it. And we have extra thing. Cannot raise IO error. Wait. Extra dot. Save. Now it's good. Create directory cannot raise IO error. What? Why it cannot raise IO? Okay, if we'll just grab that, it will be exceptions OS error. I guess it cannot do IO because IO is something special. Object of catchable error. Okay. We don't worry about that anyway. I think we would be able to define our own errors, right? So how can I define my own error? It was right here, right? IO error is type of catchable error. Okay. That's good enough. And something like OS error could have an error code and some other things. We have catchable errors, value errors. Oh, okay. And then we have defect. Object of defect. I guess defect is when there's something wrong with your values, I presume. Okay, but we just do catchable error. So, oh, and this is how you write documentation under it. Don't like it right now. So in CommonFS, let's just specify that we have the you know, our type here, but let's also specify the errors. Like it would be nice to have something like file system error, okay? This whole generic thing, raised if there is something wrong with the file system, comma, comma, let's do EG, that's how it is in English. For example, partition, OS partition is no longer available. SFTP connection can't be established, etc. Okay, so we can specify that this raises file system error. File system error. Okay. Can I do this? It cannot raise it. Why not? Hasn't been implemented. Can raise an unlisted exception. Library error. Okay, so this is suddenly complaining that this can raise library error. So I guess we should add that, right? Save that, and this is what we can anticipate. Now we won't complain here. It just complains that I guess it can raise this exception. Because I was hoping that we could define all those possible exceptions for each specific operation, right? We can get rid of those two that, you know, are not existing yet. And then the actual implementation of it would need to follow it. Because what happens if I'm going to, you know, first copy it, right? We go to OsFS and we just do this. So it will be OsFS. And it's not a base. And we don't specify what exceptions it can raise, okay? We just save it. We don't need that one anymore. And what's gonna here? Let's specify no side effects and GC save. So that's how it's, I guess, it's being compiled, that it's GC save and no side effects. But it doesn't specify what it raises. So I guess that's the limitation here. We just can't get that information. Let me check something. Let's go to the browser. Let's go to the nym docs. Let's go to the scary place. Where is it? Somewhere up here. No. Language manual. That's it. Somewhere on the bottom, I believe. Let's go all the way to the bottom. Threads, guards and locks. All that. Pragmas, modules, macros, special types, templates. Effect system, okay? Because this should describe it. No, the rules for effect tracking changed with the release of version 1.6 of the nym compiler. Great. We're already past that. Oh, this is nym compiler. I guess that's the same. So exception tracking. nym supports exception tracking. There we go. That's what we're trying to learn about. The raises pragma can be used to explicitly define which exceptions in a proc iterator method converter is allowed to raise. Okay? Converter, that's a new one. The compiler verifies this. So if we do the proc p of what, and we specify that it raises IO error and OS error, and we have this and that, okay? An empty raises list means that no exceptions may be raised. Also, if we do that, we're actually not allowing any anything to happen here. We cannot raise, we have to catch everything. Okay, now it makes sense. So we can force ourselves to make sure that this thing cannot raise a single exception. A raises list can also be attached to a proc type. This affects type compatibility. So the type callback proc, okay, so if we say that this callback is a variable of type procedure and it raises that, okay, makes sense. For routine P, the compiler uses inference rules to determine the set of possibly raised exceptions. The algorithm operates on P's call graph. Every indirect call via some proc type T is assumed to raise system exception, the base type of an exception hierarchy. And thus, an exception unless T has an explicit raises list. Okay. However, if the call is of the form f something, where f is a parameter of the currently analyzed routine, this is ignored. Okay, this is complicated. Every expression E of some proc type within a call passes. But what about methods? Blah, 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 blah. I'm just trying to peruse through that. Every call to a method M is assumed to raise system exception as M has an explicit raises list. Okay. Right. Wherever I'll call blah, blah. Exceptions inheriting from system defect are not tracked with the raises. Exception tracking, I'm like, oh, so defects aren't tracked. Interesting. This is more consistent with the built-in operations. So if we do that, even though it could raise the division by 0 defect, you know, it's still valid because it's the defect. Oops, effect off. Where did it go? Effects off. Was 1-2 of the exception tracking reference rules. Ensure the following works. We don't raise, but maybe the callback. Callback procedure raises effects off callback. Okay. Oh, so we can specify that the callback might raise something, and therefore, if we pushed, you know, did use and did the fallback, okay, can raise IO error. Exactly. Okay. Okay, that makes sense. We can assume that something's gonna be something that we provide to it might raise something. Okay. As can be seen from example, parameter, blah, blah, effects of one raise. So in many cases, a callback does not cause the compiler to be overly conservative in its effect analysis. Okay. Push, warning as error effect is on. Okay. Tag tracking, so that's different. Exception tracking is part of NIM's effect system. Raising an exception is an effect. Other effects can also be defined. A user-defined effect is a means to tag a routine or to perform checks against it. So we have type IO, which is an object. An input-output effect. Okay. Then we have procedure read line. We'll define it that returns a string and has tag IO. Procedure no effects, please. And we specify that we don't want an effect, so we can't do that. We don't want any IO. Oh, wow. Okay. So we can specify the only allowed tags. Or instead, we could just say forbids to, because tags is like a whitelist. You list only the things that are allowed, while forbids is more of a, you know, which ones are forbidden. Okay. Makes sense. Side effects and GC safety effect, effects pragma. Okay, but this doesn't specify how it works with inheritance. That's too bad. So maybe we won't be specifying that yet. Let's just think a little bit more about, let's try to implement it. I'll ask questions maybe on the Discord. Maybe I'll ask questions on Discord for NIM, and that could help out a little bit. So let's see if I can do that here. Okay. Do this here. Up. And let's go with main. This is NIM. NIM Discord. Let's go to main, unless we have something like a topic, tooling, internals, NIMConf, and everything else is a bit different. So let's try to ask here. As far as I know, this is a very active Discord, so if you have questions about anything NIM related, hey, go for it. Join up and it could be fun. So let's try this. I'm trying to learn about the raises pragma. I understand how it works roughly, as I read the manual section, the section of the manual that talks about it. Okay? That's what we just did. But how does it behave with inheritance and methods? So let's give some code, right? And our code we can actually copy from here. Let's grab it. So we have our type file system, right? And our catchable error. And we can just take that, we specify also a method. Yeah, something of this sort. Okay. And then we want to have the type OsFS. And we would like to do something like actually implement here and raise some errors. Okay. Let's copy this part. Okay, we'll paste it here. We'll have this here. We have this procedure and whatever. How can I make it so that when using, let's actually take a piece of our hello. We do this, and we'll just do the create directory, right? Because that's what we're implementing. We do create directory path. We just have that. Okay. We'll just specify this is a file system. Okay. Use the method here. How do I handle? How do I? Whatever. So let's specify it. And first of all, no, it's too much indentation everywhere. Okay. Let's take those out and put them at the end here. So the idea would be that in the code above, I have the base object of file system that I define create their directory method. Then I have OsFS. That's how I called it. OsFS. Okay. That inherits and override type that overrides the create. How the end code will whatever the usage of the code will be operating only on the file system type. It won't be directly aware of OsFS. How can I make it how can I make the compiler properly aware of all the possible errors that create directory can raise, where different implementations of it might raise different sets of errors? Let's post it, see what happens. That's not an answer, but okay, we've got that. We'll see if we're gonna get an answer at some point. Right now, let's just go to our CommonFS. Let's completely ignore the raises thing. We'll just let it the compiler figure out that, hey, it could be anything. And we have that. And let's think about how we can actually implement our create directory. Okay. From now on, I'm gonna actually enable how can I enable completions? We'll see if compiler will be working against us or for us. So far, it's not very smart. Okay, and using spaces too. Okay, I need to check how to do it like globally. I'm not used to using Visual Studio too much. Visual Studio Code, I mean. Okay, so how do we create directory? I recall that we had something like that. Can we just do create directory? Yeah, we don't have that, so let's look it up in our this was just the manual, but we should be able to go to standard library. Okay, and where did we have all those basic things? Wasn't it in something with directories, right? String handling, generic operating system, directory. Create directory. There we go. So it will be std/directories. Let's try that. Import as directories, or more like import from std directory, import what was it? Create directory, I guess. Procedure, yes, that's the thing. And can we specify it as create directory fs? There we go. I guess that's how Python would do it. I presume. Last thing I did in Python was long time ago. Okay. So we can try to do here, and we do create directory fs, and we should be able to give it the path, right? But what is it expecting? It's expecting found. Ooh. I guess it's not happy about that after all. Create directory. Undeclared identifier expected, but this and that. Let's look at the tutorial again, because I recall that we had it properly done, right? We were reading about it today. This, and we saw an import somewhere here. It was close enough here. From this, import that. Okay, so we just don't do this. Okay, save it, and that works. As creator FS. Nope, it doesn't like the as. So we just do that. Okay. Okay. So this refers to theirs. Okay. And it expects a path. Okay. And doesn't show as it's throwing anything. And doesn't return anything. I guess that's an implementation for now. Well, that was low effort. I must say. Didn't expect that low effort. And let's just check here if we get anything. We derive from common error. As you've done, there is nothing else you can do if you're doing exception-based exceptions. So this doesn't answer much for us, because as you've done, there's nothing else you can do if you're doing exception-based exceptions. You annotate the base raise for all the root exceptions your base should raise. This forces all our children to be a subset of those raises. Okay, so that works. But now the compiler isn't happy that my base isn't throwing all the listed exceptions. So let's actually check that, because we can copy part of the code that we had here, right? It raises this and that. Okay. So in our CommonFS, we just do comma, bam, raises this and that. And valid pragma base. Oh, the period stayed here while this needs to be here. Okay. Say that this is unhappy. Let's go to our hello and make sure that it's actually runnable. We create directory path. User. Let's do, I believe, this slash. What was it? That's a home directory, I guess so. And let's do test directory, okay? Let's try to create this directory. And now fs.create directory and path isn't happy. Has no type. Huh? Path is path. Oh, because this doesn't return anything. So we just call this and read kittens. We don't care about kittens. And suddenly tempting to call undeclared routine. Create directory. Sorry, but it is declared. And this suddenly complains. Oh, because this can raise unlisted exception, OS error. So let's do try, right? Let's try that. And now we accept OS error. We can raise newer exception and we'll call it something. Well, what was it that we were allowing? File system error, okay? So we need to make file system error it's available. So let's do file system error. Okay. And this is not nim. And that's how it works. Can raise it, but we're literally have try catch here. Ay. You know what? Let's try to run it. Let's try to run it and see what happens. We have hello nim, and let's try to run it. So time generate instantiation from here. Error creator can raise an unlisted exception. Reference IO error. So how do we go over to the actual? Too many browsers and tabs open. I'm getting lost in here. So how can we actually handle those exceptions? We had it somewhere here, right? So that, try something, accept this, and handle it, and then return it, right? We did that. We just did that. So what the hell? OsFS. We try create directory, and if there is an exception, we handle it. IO error. Oh. So let's do accept IO error. And we do the same thing. Save. Only a ref object can be raised. File system error isn't ref object. A ref object. There we go. And blah blah blah. Let's try it. Object constructor needs an object type. Ha! Object constructor. 1523. Okay, so this nim suggest is really confusing. Save. And run again. Oh, not this. This shortcut. Oh, there's some progress. Warning, use space for base methods. Baseless methods are deprecated. Huh? In memory file system. Oh, okay. So we don't want that here. Okay. We just ignore that here. Let's restart it here. Important and not used. Paths unused import. And that's inside and memory FS. Okay, sure. Just ignore that for now. Okay. Oops. Let's go back to our hello. So did we just create that path? Can I just go to terminal? We are in here, so let's go and D S. We are. What the hell? We're home slash that. Oh, we just created some user thing, right? Well, we don't have user thing here. And it didn't raise an exception? What the hell just happened? Go away, go away. Run it again. Cannot create directory file system. Okay, there we go. So let's fix that in our hello nym. We want /home /this /test directory run. And it didn't throw any exceptions. So I should be able to go to bash to the what is it? Home directory. CD. And now here we have the test directory. There we go. So it worked. It actually created a directory. I'm very happy about that. Okay. At least some progress. The tiniest little progress, but progress. Okay. And nimsuggest just freaks out. It can't figure out anything. But this worked. And the only problem here it has, we imported thing and we have some unused imports in here, and that's pretty much it. Okay, that makes me very happy. So let's just real file system module, get file, all that. We don't need that anymore. This is old stuff. Okay, we have CommonFS. We don't want to deal with memory FS right now, so we can just comment it out. And that's pretty much it. Let's ignore all that. We don't want to do it. We want to just do an actual path. Okay, that path. And this should work as well, right? Let's rerun it. Right? Okay, it's all good. Very good. Very happy about it. Okay. And so we defined the whole thing here where we said that it can raise this and that. This complains here a little bit, but we are not getting any errors or complaints during actual compilation. And here, if we try to raise something else, like this, will that be a problem now? Compile it. Yes, look at that. Create directory can raise an unlisted exception. Ref OS error. Okay. So this is how we can handle it. We would just need to figure out when it's throwing which errors. The directory may contain several subdirectories that do not exist yet. The path is created. If it fails, OS error is raised. So this will be just an error, okay? File system error. And We do not know why. Okay. And it does not fail if the directory error exists, because for most usages it does not indicate an error. And that's perfect. An IO error, oops, is I guess like the generic one. No big deal here. So yeah, that makes me happy. All right. Cool. I can live with all that. Yeah. So I guess we found a way to deal with those exceptions. We just specify them here, and over time we'll just grow a list of exceptions that we want to have available. And yeah, that's pretty much it. Okay. Can I just show the non-error thing? Okay, so what time do we have? We have nearly 1 a.m. at least here. So let's just try to quickly implement one more thing. Now it should go way faster that we already started. Let me just thank that guy that he responded to us. Okay, I see. It actually works that way. Thank you. The nym suggest confuses the hell out of me. And how do you make this smiley face upside down? Upside down. There we go. And we can get rid of that. Cool beans. So what was our next objective? We went through what were suggestions of our create directory? Access denied, path already exists, OS error. Yes, in our case, excuse me, we have just one generic error. Checking if directory exists. Okay. So let's do it here. We can get rid of this whole part here, right? Because it's not needed. And how do we make the documentation? Like this? It does not raise an error if the directory already exists. Okay, cool. That's defined. So let's go further, method, and we do, what was it? There exists. File system path, return bool, raises library or file system error, returns true if the directory at the specified path exists, and we just have the generic non-existing implementation. So we can go back here and we can basically do method directory exists, bool and return, and that's where we need to check how to actually deal with checking if it exists or not. So hit nym docs. Can I duplicate it here? Yes. Let's just go down here and we will go to our standard library again. We had our directories and we have there exists. There we go. Returns true if directory exists. If directory is a file, false is returned. Okay, so it does not exist. Follows symlinks. Okay. And I guess it has its own bunch of possible errors. So import create directory, comma, there exists. And we can basically do try, return there exists, and let's actually do that. I'll just copy this here. Okay, and let's just comment this out and let's see what happens if the compiler will be unhappy. I guess the compiler isn't unhappy. Again, wrong. Okay. So let's do if fs dot what's the name? Directory exists path. Okay. We don't need those parentheses. This is different language. And echo directory already exists. And then we do else. And we have this and do echo directory created. Okay. Let's see if that works. Bam. Directory already exists. Okay, so we see that this, when we're calling directory exists, we're not getting any errors. None at all. While we'll define that we could throw some. Okay. Path exists if the path points to file and returns false. Sure, that's gonna be helpful here. Okay. Hey, we just checked off another box. Remove directory. That's gonna be more fun. And let's see if that's in our recommendation here. Remove directory. Removes the directory, including all subdirectories and files in directory recursively. Okay, so this is just, you know, rm, rf. If this fails, OS error is raised. This does not fail if the directory never existed in the first place. Unless check there is true. We don't want that. So we can just use that. Okay. Okay. I like it. So let's go and let's go to our code, CommonFS, and we do method remove directory. And we do this whole thing. Same, exactly. Remove the directory at the specified path. It does not raise an error if directory does not exist. Perfect. Look at that. We don't need to write any code. Okay, and for FSOS, we'll basically do method remove directory. Okay. And this is wrong implementation. We'll just do comma remove directory. And we can do, does remove directory return something? No, it doesn't return anything. Okay, tags, write directory effect, read directory effect. Okay. So will be remove directory path. Okay. But now this will be unhappy because it can raise OS error. So we need to do the whole try catch thing. That was OS error, I presume. So we just did that. Except OS error raised. Cannot delete or delete directory. Well, let's try that. Okay. So if it exists, let's try to remove it. Okay, if it exists, removing or deleting. Okay. Let's do fs remove directory. We'll give this the path and echo directory deleted. And then directory created. So this will force compiler to compile it. And it looks like we handled everything. Okay, good. Of course, if this will crash, we will have a problem. So delete it. So, okay, so next time we run it, we'll create it, right? Create it. There we go. So what if I'm gonna create a file? Let's actually try it out. So let's go to cd test directory. Okay, there's nothing here. Let's do nano random file.txt. This is some random file. Exclamation mark. And we saved it, right? And we have the file, okay? 26 bytes. So if I'm going to run this code now, directory deleted, and I'll go here. Whoops, come on. Too many buttons everywhere. Total 0, nothing. If we go back and list directories, there's no such directory. So we just cleared it all up. That's awesome. Okay. Hey, we just implemented 3 things, and we can create, check for directories, and remove them. So we could, in theory, remove them and do all the fancy stuff. Okay. I think we'll be calling it for now. So let's just add some nice check marks. Okay, that we did those. 1, 2, 3. Okay. I don't think we'll be going over work directory yet, but next time we'll do create file, check if file exists, and remove file. And that should give us some idea what to do. And I wonder if create file, from that, if we're maybe gonna return like a handle to a file, right? Let's add that, and therefore that'll be our next challenge. Maybe we do those 2, and then create the ID of the file, and just bam. And that could be something to deal with. Okay. I'm very happy about that. So we can finish for now, as the stream is already 2.5 hours long. And I'm getting tired. So thank you for watching. Thank you everyone for watching. And remember, you can subscribe on YouTube. You can like the video if you liked it. You can follow me on Twitch. And on top of all that, after the stream is done, you can, feel free to comment too. And at some point, this video will be also chopped up into smaller little chunks as separate videos, not as a long live stream. And in those videos, I'm always trying to cut out all those moments where I'm looking at the other screen or searching for something, so they're a little bit faster to watch. So again, thank you for watching, and see you next Friday.